So we've been working with square roots and cube roots and other kinds of roots, and we've learned that in some situations we run into a problem when we're trying to take the square root of negative numbers. Well, we need a solution to that, otherwise we just hit dead ends. And so now we got to use our imagination a little bit. So let's think about this situation here. We've got, let's say we've got an equation like x squared equals 9. Well, the opposite of squaring is square rooting. And so what number can you square to get 9? You can square 3, right? Now, you can also square negative 3 because negative 3 squared is 9, all right? And that's something that will come up more in the future in our next chapter. But we can square root 9. That's the idea. All right. Can we square root decimal numbers? Sure. You can square root decimal numbers. This comes out to be 2.5. And we'll throw the negative number in there also. Okay. Negative 2.5 times negative 2.5 would be 6.25. Okay, so we can square root positive numbers. We can square root decimal numbers. What about numbers like 2 that's not a perfect square? Well, yeah, we've seen that we can square root that. We just end up with an irrational number. Irrational number means it never ends and it never repeats. And we'll make note we can also get the negative version. Okay. So square root of 2, we've seen it's an irrational number. It's about 1.414. What about negative 1? What number can we multiply by itself to get negative 1? Well, there is no real number. Or we can say there's no real solution. All right? However, what we're going to do, and what mathematicians have done in the past, is said, well, we need to move forward here. We're not happy with just saying there's no answer. So let's just make up a number here, kind of, and let's just call this I. We'll give it a name. Whenever we hit the square root of negative 1, we'll call that I, and we call this our imaginary unit. All right, square root of negative 1 is I, which is our imaginary unit. And that's going to allow us to kind of move forward. And it turns out that this opens the door to a whole bunch of mathematics. And we can do some pretty powerful things with it. And so these numbers were used first around 1500s by a guy named Jerome Cardan is credited with it. And so, up until about the 1500s, we just were stuck with negative the square root of I, all right? So, how can we use this? Well, now if we have the square root of negative 36, this is, we can write this as the square root of 36 times the square root of negative 1, right? There's our product rule. Okay, the square root of 36 is 6, and the square root of negative 1 is I. So the square root of negative 36 we'll write as 6I, because we can't square root negative numbers. Well, if that's the case, then we can write this as the square root of negative 1 times the square root of 5. I don't know what the square root of 5 is, so we can leave that alone, but we can do something with the square root of negative 1 now. We'll write that as I. So we'll call that I square root of 5, or sometime we'll even abbreviate that. We'll just say I root 5. So if you hear someone say I root 5, it's not like Route 66 that you go driving on across the United States, but this is root would be the short for square root, all right? So square root of negative 20. Well, Here we can break this up into the square root of -4 times the square root of 5. Now, we don't know the square root of 5, as we've just mentioned. We do know the square root of -4. Now we can write it like this, okay? We're not going to always break it up like this. Once we see a negative, we can kind of skip that step I just did a minute ago and breaking it up. It's going to be 2i. So anytime we have a negative, we can square root it, and we're going to get an I that comes out. Okay? So that's the basic idea of using the imaginary unit I.